Watching this video right now, you're probably looking up on information regarding Monty Hall problem. There are many versions of explanation for this problem. In this video, I'll refer to the version which I think is the simplest and explain the math behind this problem. So I'll do it by playing a simple game with you. So in front of us right now are three paper cups labeled with A, B, and C. And they are all empty. So just to show you what is inside all this cup. Okay. And we also need a $100. Okay. I have $100 here. So what I'm going to do is that I'll secretly put this $100 into one of these three cups. So I'll do that secretly by blocking your vision. Okay. Okay. So now one of these three cups contain the $100. You then choose your lucky cup, which you feel is the one that contains the $100. So if you have chosen the cup correctly, then you win the $100. Say you have chosen cup A. I'll then pick one of these other two non-chosen, non-revealed cup to you and to show you what is inside the other two cups. Okay. Say I reveal cup B to you, okay, which is an empty cup. I'll always reveal an empty cup to you, okay. And now at this moment, you'll be given an option to switch your cup A with the non-reveal, non-chosen cup C. So we'll name the cup that you have choose before revelation as the first choice and the cup that you choose after revelation as the second choice. The question right now is, should you switch your cups in order to increase the probability of winning the money? Okay, let's turn on the cheat mode for better explanation. So by turning on the cheat mode, it means that we overturn all the cups to show you what is inside this cup. So if you are not switching your lucky cup, then your chance of winning the $100 is only 1/3, since there's only one out of these three cups which contain the $100. If you are switching your lucky cup after I have revealed the empty cup to you, it can be either cup B or cup C, doesn't matter, as long as I reveal an empty cup to you. So if you're switching that after I reveal an empty cup to you, your probability of winning the money would actually increase to 2/3. Okay, instead of 1/3 now, if you switch, your probability will increase to 2/3. So how is that possible? Okay, let's say in scenario 1, your first choice was cup A that contained the money. Okay, let's say in the first scenario, your first choice is this cup A which contains the money. Then I reveal an empty cup B to you, okay, and reveal an empty cup B to you. And then you switch your cup. So you switch your cup A with cup C. So now your second choice is cup C. So in this case, you end up not winning the money because you have switched your cup A with empty cup C. Okay. So in this case, what is the probability of not winning the money? The probability of not winning the money in this case is 1/3, because you only end up not winning the money if you have chosen the cup which contained the money in the first place as your first choice. If you have chosen the cup with the money, then you switch, then you end up not winning the money, because the probability of selecting a cup which contained the money in the first place is actually 1/3 only. And after switching, you get an empty cup. So the probability of not winning the money in this case is actually 1/3. Okay. Now in the second scenario, let's say your first choice was either cup B or cup C, which does not contain the money. I'll then reveal cup C or cup B to you, and then you switch cup. Let's say you've chosen, in this scenario, you've chosen an empty cup C as your first choice, and then I'll reveal cup B to you, and then you switch your cup C with your cup A. So cup A is the second choice. In this case, you end up winning the money. So you end up winning the money by choosing an empty cup in the first place. After that, you switch your empty cup with the non-reveal, non-chosen cup, which is the cup that contains the money. So in this case, your probability of winning the money is actually 2/3, because this only happens when you have chosen an empty cup in the first place. And the probability of choosing an empty cup in the first place is actually 2/3. So if you have chosen an empty cup in the first place, after that you switch, then you end up winning the money. Okay. So in this case of 3 cups, the revealing and switching processes actually swap the probability of winning to not winning and vice versa. Take note that this probability switching or probability swapping is only true in this case. If there are more than 2 empty cups, then the increased winning probability of switching will have to be based on other type of explanation. Okay, and finally, Monty Hall Problem is actually based on American game show, an American game show. So in this game show, there are actually 3 doors, and there's a car behind one of these doors, and a goat behind each of the other 2 doors. So a participant will then choose a door which he or she thinks encloses the car. The host then reveal an empty door and give the participant an option to switch the door. So in this game that we have played is actually a modified, simplified version of this Monty Hall Problem. We've actually replaced the car with $100 and the goats with empty cups only. Okay, I hope this video would explain the Monty Hall Problem, the maths behind the Monty Hall Problem to you in a simple manner. So until we see again, bye bye.